Good morning. So the topic for the day is force vector. So I am E. Ilavenil, Assistant Professor, Department of Mechanical Engineering, Thandai Periyar Government Institute of Technology, Vellore. Force. So force is an action or an effect that tends to move a body in its direction. So only a tendency is compulsory here. Whether the body will move or not depends upon the conditions and the factors involved. So in statics, a body never moves, but the tendency is observed through the reaction that follows the force. So a force is characterized by a magnitude, a direction, and a point of application. So whenever two forces are said to be equal, they are equal only when all these three factors are equal. Varying any one of these factors is going to vary the force. That is, if the magnitude and direction are same, but if the point of application is different, we cannot say two forces are equal or same. And again, when a force with magnitude and point of application are same and direction is different, again those two forces cannot be termed equal. Obviously, a force with a different magnitude but with same direction and point of application can also not be considered same. That is very obvious. So as a force is characterized by three factors, that is a magnitude, a direction, and point of application, all these three are to be same for two forces or more forces to be considered equal. So a force having both magnitude and direction is termed as a vector quantity. So that is why we call the force as a force vector in many cases. Action of force. Force acts on a body, and in statics its action creates a reaction which is also a force of equal magnitude and opposite direction. Normally, the reaction produced is referred as external reaction that again tends to move the body. Again, this tendency is also only the tendency that is observed, and in statics it is not a movement or which is not able to create any movement there. So there is also internal reactions that tend to deform the body. So in engineering mechanics, we ignore the internal effects of reactions. As said earlier, they are studied under different title. Unit of force. The SI unit of force is newtons. So this is what we are going to follow and use. This is denoted by the letter capital N. So 1 Newton is a force required to accelerate a 1 kg mass at 1 meters per second acceleration. So in MKS units, force is expressed as kilogram force. So this is the force produced by 1 kg mass under the action of gravity. So 1 kgf is equal to 9.81 newtons. So kgf is also sometimes denoted simply as kg itself. So at very few places we are also going to use this unit kgf, where but we highly prefer Newton as the unit of force. Vector representation. Being a vector quantity, force of magnitude capital F is denoted by a bold capital F. So the bolded F refers to vector. The actual notation here would be an arrow on the top of that quantity F here. So for computerized usages, using bold letter vectors would be convenient, and even certain very standard textbooks also do that. That is, represent vector by bold letters. Vector components. Since vector along with its magnitude is often insufficient, we need to represent the direction also. For example, 24 Newton as shown here at 210 degrees is how we may be indicating that force, where the angle would be measured from positive x-axis in the anti-clockwise direction. Of course, that is a standardization, but more convenient would be representing it with multiples of unit vectors along the rectangular components, that is I, j and k unit vectors in the directions of x, y and z axis. So force vector. A force vector is now represented as F is equal to Fxi plus Fyj plus Fzk, where I, j and k are unit vectors along x, y and z directions as already indicated. Here Fx is the magnitude of x component of F, and Fy the magnitude of y component, and Fz the magnitude of z component of that vector F. So here I, j, k are unit vectors, which means their magnitude is 1 unit. So for example, F vector is equal to 3i plus 5j plus 4k newtons. Magnitude and direction of a vector. So when we express a force vector as F vector is equal to Fxi plus Fyj plus Fzk, its magnitude F, of course here without bold, it is the magnitude F is equal to square root of Fx square plus Fy square plus Fz square. And here the directions are represented through the direction cosines that are cos theta x equal to Fx by F, cos theta y is equal to Fy by F, and cos theta z is equal to Fz by F, from which by taking cos inverse we can get theta x, theta y and theta z. So in this lecture we have seen what a force is and what are the factors by which a force is characterized. We have seen. So what is the action of a force? We have seen. So what is the unit of force and what are the different units that we have seen? We have seen a vectorial representation of force. and we have also seen how to obtain the magnitude and direction of a force vector. So with that, we'll stop for this day. Thank you.